Okay, welcome. This is Mr. Dahlstrom from Pre-AP Physics. This is the worksheet that we are working on Monday, August 24th. This is for my students that are at home. So there is, I put this up on Schoology, so you should be able to complete this. There are 6 problems, but I wanted to take some time just to talk about something we talked about in class about number 6. This is in relation to a lecture that we had on Thursday or Friday in terms of conceptual. So there's going to be a quiz tomorrow on our horizontal constant acceleration. I just wanted to talk about this here real quick. So look at number 6. This shouldn't be too long a video. Hopefully we can keep it under 10 minutes for that. So first one, it says a child is riding her bicycle to the left with a speed of 4 meters per second. She then applies the brakes and slows down to a stop in 8 seconds. So the first question is, what is her acceleration? Second is, how far did she travel before coming to rest? And the last one is sort of the conceptual understanding. Does the direction signs on your answers make sense? Explain your reasoning. So actually, before we do that, I want to kind of talk about what we should predict was happening here. So we talk about sometimes it's helpful to draw a picture to see what's going on. So I'm going to draw a really nice picture of a child on a bicycle. There we go. That's an awesome picture of a child on a bicycle. And we have to learn to not be number hunters. I keep bringing this up. Don't be a number hunter. A number hunter is just somebody that doesn't pay attention to any context and says, oh, a child is on her bike. Okay, she's going 4 and 8 and all that like that. But if you don't pay attention to the context, then you're going to get this problem. Not only is it going to be incorrect, but it's not going to make sense here. So we have to pay attention. It says the child is on her bicycle and she's going to the left with a speed of 4 meters per second. So we have to remember the difference between speed and velocity. Speed is basically how fast. So how fast. And the only difference between speed and velocity, if you think about the speedometer in your car, your speedometer in your car, it's only telling you how fast you're going. It's not telling you which direction you're going. So velocity, sorry for my handwriting, is how fast and basically what direction it's going in. So we have to realize here that the problem is telling us what the speed is, but it's also trying to tell us what the velocity is. And so it's not always going to be just straight out saying, hey, velocity is negative this or that. So we have to basically figure out what this is telling us here. So the speed of this child is 4 meters per second. There's no mention of which direction it's going in. The velocity of the child on the bicycle, sorry, it's more in my handwriting, still getting good, is going to be 4 meters per second. But if we wanted to denote left, seeing that left is traditionally negative, we'd say -4. And that's a really big thing. So if we wanted to show that kind of in a picture here, and how we did this on previous notes, I'd say that she has a negative velocity here, which means she's moving to the left. And we have to also understand, we have to predict. I want to make a prediction of what kind of sign we should have here. Should we have a positive or should we have a negative? And then the same thing for our delta x. Should it be positive or should it be negative for that? So first of all, let's think about here. She's going to the left. She then applies the brakes and slows down to a stop. So we know that she's slowing down. And the misconception about slowing down is people always think, oh, negative acceleration, that must mean you're slowing down. That's not the case. You have to look at the original context of the problem. Oop, my lights just went off my room. The original context of the problem. The girl is moving to the left, and we talked about this before where basically, and I can't really show you with my arms here because you can't really see it, but if we have somebody that's moving to the left and we wanted to show somebody slowing down, that means that the acceleration has to be in the opposite direction. The reason why this is important is basically all the problems we worked on up to this point have been the second scenario here, where the object has been moving to the right, and in order for it to slow down, it had a negative acceleration. So sometimes this causes a misconception. This is correct for something moving to the right and slowing down. This is correct for something moving to the left and then slowing down. So we should expect, if she is slowing down because it's moving to the right, the acceleration should be positive, so we should expect a positive acceleration. And then the next one, how far does she travel before coming to the rest? So she's traveling in the negative direction here. So if we're trying to think about whether or not she's going to end up over here on the left or whether she's going to end up over here on the right, it doesn't make any kind of sense. If she's traveling to the left and slowing down and moving through time 8 seconds, we would expect that her delta x is going to be somewhere over here on this side. And for delta x is somewhere on that side, it would make only sense if the number there we got would be negative. The reason why this prediction is very important is that if we don't get these answers here, that either means that our conceptual understanding is off, and I think we've talked through this. This is what makes sense here. But if we don't get a positive acceleration, we don't get a negative delta x, that means that something is wrong in our calculation. So we need to realize that even though it says a speed of 4 meters per second, that left there is telling us our velocity is -4. So if we were just really quickly filling out the, you notice that the spaces aren't here that show us what the variable should be. I want you to kind of get used to doing what I'm doing here and filling in these to help you solve their problems. So delta x is something that we are trying to find eventually, but we'll go ahead and just plug in what we know. The 4 meters per second, or the -4 meters per second for velocity, is her initial velocity. And she's coming to a stop in 8 seconds, so that means her final is 0. I may have that in opposite, 0 meters per second. And we know the time that it takes is 8 seconds. So the first thing we're trying to find is acceleration, and then obviously delta x. So I'm not going to solve this one completely throughout. We have enough problems. I don't want to make this video too long. But when you do solve for that, even though I have the answers down here, when you do solve for that, you do get 0.5 meters per second squared. Now realize that is a positive. You don't have to indicate that. It's already assumed to be positive because there's no negative there. So that means that it's slowing down, going to the left, positive acceleration, slowing down. That makes sense. Okay, and also what we said about how far she should move. She should have moved in the negative direction because she was already moving in the negative direction. And so the fact that this is a negative number also makes sense. And so that's sort of the reasoning behind that. So that's really what I wanted to talk about today in the video. I'm going to go ahead and kind of sign off. I'll put this up on YouTube for whoever wants to watch with it. Basically, this is just a conceptual understanding of the video. I do recommend that you subscribe. More people subscribe, the more my videos get out there, the more people I can help. It's about helping everybody, not just everybody at the school that I work with. So appreciate you listening. We did get it under 10 minutes, so I will see you in another video. Thank you very much.